What up, dudes? How's it going with you? Can you hear my voice? All right, you folks are asking about the fall break. Whoa, 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 whoa. Why is the audio going? Let's do this thing right here and turn off. There we go. Now we get rid of that annoying beep. All right, cool. You can hear my voice. Awesome. Did you guys get my Did you guys can see my computer screen? Cool. Okay, good. Then let's get this party started. So, what we've talked about today is the vertex form, and we've been kind of going through this really quickly. If we set this thing equal to 0, we're able to if we set this thing equal to 0, we're able to easily find the x-intercepts. And that was what your homework was. I think that was due like today or yesterday or something like that. It was like 4.2, I think. All right. But what's nice about things in vertex form is being able to graph them. Because in vertex form, this graph comes out really nice. Now, Ciara, I remember that you're definitely, like when we were doing tutoring yesterday, I feel like you really got this. So I want everyone to answer, but I totally expect you guys to be able to throw up an answer here. Let's graph this x minus 5 squared minus 8. And let's take this, let's do this negative 8 right here. All right, so the vertex, all right, Sophia's already got it. The vertex is at positive 5, negative 8. My question really was, what does the negative 8 do? All right, it takes my graph and it moves it down 8, exactly. And then what does this negative 5 do? Do you guys see this negative 5 right here? All right, what does that do? It moves it to the right, exactly. So it moves it to the right. Yeah. A number inside the parentheses moves things to the right and left. And when moving things to the right and left, it does things a little bit backwards as to what we expect it to. When moving things up and down, see that negative 8? That totally does what we expect it to. It moves it down 8. Whereas over here, moving it to the right, left, it actually moves it the opposite of what you think. If you think it is going to go left because this is a negative 5, right, and negative is the left direction, it actually goes to the right 5. And that's just kind of an interesting thing. I'm going to go to Desmos, and I'm going to cheat and graph a lot of these by Desmos. What? No, I want Desmos graphing calculator. There we go. So I'm going to graph x minus 5. Whoa. X. Oh no, I get it. The shift key is stuck. X. Okay. X minus 5 squared minus 8. All right. And then what I'm also going to do is I'm going to graph x squared. X caret squared. All right. So see, this x squared is the regular parabola. And then this parabola got pushed down 8 units, as you can see right here. And it got pushed to the right 5 units. All right, Lucas is saying the negative is part of the formula, and h is separate. So if the number h is negative, it moves to the left. Yeah, exactly. Because we're doing that funky thing about because the moving it right and left does kind of opposite of what we think it should do. Our formula for the vertex form looks like this: a times x minus h squared plus k. Usually inside there we see an x plus h squared plus k. But to account for that wonky backwards, movement, we included the negative in there. So now we can say if h is a positive number, then it actually moves it to the right, and then that kind of accounts for things that like freak us out about like positive numbers moving to the right. You know what I mean? Does that make sense? So this is why the formula for the vertex form looks exactly like it does. So we can talk about like all of this stuff, like this -2 over here. What does that do? Moves it down 2. Good. What about the 8? What does that do? I want everyone to answer. I'm waiting for everybody. Moves it to the left 8. Very good. And what does this 2 over here do? Vertically stretches it. It makes it skinnier. Exactly. It vertically stretches it. It still keeps it a happy face one, though. We're still dealing with a happy face. It's just a skinnier happy face. In fact, if you want, go into Desmos graphing calculator, and I want to try doing something. Let's do this. Go into Desmos, type in this. A times x minus h squared plus k. Yes, you can use Desmos to check your answers. That's not cheating. But open up Desmos. I want you to type this in. In fact, I'll chat it to you. I wonder if this thing ends up. Let's see. Click here, chat this to the students. Try copy paste that into Desmos. You guys got it? Now it should look something like this. And then it says add slider. Let's add a slider for all of them. Cool? I want you to make the h 0 and the k 0. All right, so when we added the sliders, we can see exactly when we move the h up, what is that doing to the parabola? If I'm making h positive, just to get this straight, h is already negative. By adding a negative sign, it makes it positive. Yeah, no, exactly. Okay, check this out. I'm making h a positive number. Right now it's positive 2. Okay? The reason why making this positive moves it to the right is because we threw in this negative already in there. Does that make sense? So h equaling positive 5 makes it x minus 5, which moves it to the right 5. Whereas h equaling -6 makes it x minus -6. So inside the parentheses, you would see x plus 6, which means move it to the left 6. And if you play around with the slider, you can see how this thing works. So because we wanted this thing to kind of work the way we're used to seeing it, we added in this negative in here. The k, you're pretty familiar with what that does, right? And then as I mess with this thing right here, the a, it gets skinnier when the number gets bigger. It gets fatter when the number gets to be a decimal. And it gets negative when the number gets negative. Goes upside down. Does that make sense? So check this out, okay? If I put a plus in here, okay, then this thing kind of does, like as the number gets positive, it moves it to the left. And as the number gets negative, it moves it to the right. So you can kind of play with this slider to move things around. Are we cool? Does that make sense to you? All right. So the point that I'm trying to make is this. This vertex form is super useful. It's super helpful. All right. Like, we can talk about this one really really quick, and I'll just kind of discuss it real quick. This parabola, without even thinking about how to graph it, I can tell you, you move it down 16, you move it to the left 5 units, and then you're going to make this a fatter parabola than a regular one. And that's it. Got it? Now, the hard part is we need to figure out how to get this into that form. We need to figure out how to put our parabolas into this form. And for that, we're going to need to use this technique called completing the square. Now, completing the square can be tough. Let's see. I'm going to make up a few problems. I'm going to teach it to you the way I want to teach it to you, and then I'll let them do that. All right. So check this out. Let's do it this way. Let me ask this. Have you heard of completing the square? Have you done it? Do you remember how to do it? Okay, I've got a few yeses and nos. I kind of remember, not really. Okay, let's do this. I'm going to go through it, and I'm going to basically teach you how I think completing the square should be taught. Let's factor this. X squared, let's see, plus 4 plus 4x. All right, factor that. X, I know it's going to be a plus and a plus. What should it go over here and over here? 2. Perfect. All right, what about this? X squared minus 12x plus 36. X. There's going to be a minus and a minus. Do you know what's supposed to go over here? What are the numbers that are supposed to go in there? A 6 and a 6. Awesome. So if it's a 6 and a 6, is it right if I write this as this squared? Would that be all right with you? Because it's the same thing, right? Bradley, you're saying you're lost. All right, we'll do it a little slower. Let's see. X squared plus 8x plus 16. All right. Bradley, I'm factoring this like I usually do. I've got an x, and then what I'm doing is I know that there's going to be a plus and a plus, and then what I ask myself is, what times what gives me 16? Right? And Genesis is suggesting 4 and 4. But there's also other things like 8 and 2, or 16 and 1, or 4 and 4, 6, 12. There's 3 and 8, or 3 and 6. I'm sorry, 3 and 6. That works too. So we can choose these numbers, but actually, I think that what they did was they chose 4 and 4. Does that make sense? Because they foiled this out and they realized that this works. All right, good. Yeah, you can do 3 and 6. That works too. But the thing is, when I add 3 and 6, that makes 9, and that's not going to make my 8. Oh, you're right. I'm sorry. I don't know why I was thinking. Yeah, I'm sorry. I don't know why I was thinking 18. Yeah, sorry. Long day. All right. 3 and 6, don't use 3 and 6. You can use 16 and 1, you can use 8 and 2, or you can use 4 and 4. Whew, what the heck is Mr. All Day thinking about? All right. So since I have an x plus 4 and an x plus 4, I have the exact same thing. I'm going to simplify writing that a little bit. and make it a x plus 4 squared. I just have 2 of them. You know what I mean? Same thing. I have 2 of the exact same thing. I'm going to make it a square. Are we cool? Yo, come on in.
Hello. How's it going?
Okay, Chris, you're probably going to sit outside because you're not doing math right now.
Okay.
But you can ask me chemistry. Well, you can ask me chemistry questions while I'm doing it. Okay.
Yeah.
Do you want to hang out during math though, so you can watch this lesson?
Because we got bounce at 1:30. That's what it is.
You gotta go at 1:30.
Yeah, that's what the lady told us. She said it ends at 1.
Yeah.
But
We have to get back.
I have to. I start class at 2:15.
Okay, yeah.
Is in chemistry, but I'm in algebra class right now.
Oh, you're in it?
Oh.
Yeah, we're recording right now.
Oh. Okay.
Your voices are on the computer.
So,
It would probably be best. It
So,
would probably be best if you hang out here though, and then you can watch me do chemistry algebra. Can you stay? Is there any way you can stay late?
Well,
we can say a little bit later, but I mean, we have to get back to Kailua.
Can you stay till like 3:30?
no.
No, we cannot.
Okay.
Yeah, next, I cannot stay till.
There's no.
Because my dog, no one's home, and I have to come all the way to Kailua,
All
and
right.
my dog's in the house, and he can't stay in the house for more than 4 hours because
All right.
he will literally go crap in the bathroom.
Well, I can't tutor you in chemistry
Okay.
while I'm teaching.
Yeah,
Yeah, I
algebra
understand.
class. But Sky, can you hang out?
Yeah, I guess.
Sorry.
No, you're fine.
All right, sorry, folks.
I guess
You can pull up a chair if you want,
Yes, why not?
and close the door. It just gets a little hot in here.
It's okay. As long as I'm not moving, I'll be okay.
All right. No, you don't worry. I don't have the camera on.
Oh, no, it's all good.
All right, and you can answer questions if you want.
Okay.
What math are you in?
I am in
Geometry.
geometry.
Okay, then this. No, don't close all the way. All right. All right, you're in geometry. Okay, cool. Yeah, you get. All the people online are like, I feel like we're flies on the wall, lurking in on conversations. All right. Anyway, no, I'm just going over some of these perfect squares because I'm trying to introduce this concept of completing the square, and it always feels like it's magic or this like weird thing that the teacher pulls out of his butt and say, memorize this process and do it every single time, and you're like, why? Am I correct? You're like, I don't understand why you would do that. Yeah, Luke is like, no, I hate when teachers pull things out of their butt. Back pocket, that's what I mean. All right. All right. Yeah, to me it bugs me. It bugs me when when people tell me, okay, you got to do this, and I don't understand why. And I ask why, and they say just because. This is the way to do it. So what I'm doing now is I'm trying to basically show you from the ground up where all of this stuff comes from. So all we're doing is factoring a few things. I'm going to do one more. X squared, I'm just making this stuff up. How's about minus 10x plus 25? If I were to factor that, okay, I'll have an x and an x. I'll definitely have a minus and a minus. Oh, Genesis already got it, 5 and a 5. Okay. And since I have an x minus 5 and an x minus 5, we'll put a square on that and we'll just cross that out. Got it? Nothing crazy there. All right, cool. All right. Hey, Chris, I got an idea. Pull out your computer, start working on your homework. When I have a chance, if you have specific questions you can ask me, I will work on that. All right? Sky?
Yes.
You're probably just going to have to pay attention since you're in algebra class.
Yeah,
All right.
I got this.
All right. So here's the game that I'm trying to play. I want to figure out if I start with this number right here, how do I get this number? Look at this number and the one next to it and see if there's a relation between the two. If I start with the circled number, how do I get the number where the arrow is pointing to? Divided by 2. They're all halved. Good. Awesome. So let's make that a rule. So now I'm going to call this the b. Because in standard form, ax squared plus bx plus c, the b is the number that's right next to the x term, and the circled number is all the ones that have an x next to it. Right? Are we cool? So take the b and divide by 2. All right. So we take the b and we divide it by 2. Now what I want to do is I'm going to figure out a path. I want to figure out how do I get from here to there. Do you guys see the way to do that? How is 2 related to 4? How is negative 6 related to 36? Ah, there we go. Lucas has got it. You guys can say it. What is it? You square it. Exactly. 2 squared is 4. Negative 6 squared is positive 36. Positive 4 squared is 16. Negative 5 squared is 25. Right? So take your result and square it. All right. So let's try a few more of these, but this time I'm going to do it a little bit different. What if I have a x squared, I don't know, let's say minus 14x. And then I'm going to have a plus and some number here. Okay? What number would nicely go there if I wanted to make this a perfect square? Alana's got it. 49. Because 14, because I know I can do this. X minus 7, right? According to our pattern, to get this middle number over here, you have to divide that 14 by 2, and then to get that number up here, the number we were looking for, you take that number and you square it. So 7 times 7 is 49. Are we cool? So, and if I had a 49 there, that would make this thing x minus 7 squared, and it would be easy. Factoring these kinds of special things are easy, right? Let's try another one. I'll give you a hard one. How's about this? X squared minus, I don't know, let's do 16x. What number should go here? And then I'm going to do this. X squared 64. What number should go here? Negative 8. Because negative 16 divided by 2 is negative 8. That's what should go there. All right, cool. So we know how to create perfect squares. If we're given this number right here, we know how to create these perfect squares, right? All right, good. And we have a process. We have a rules that we follow. You take that b term, the term that has an x only in front of it or next to it, you divide it by 2, and then you square it. Got it? So that's not magic. Does anyone feel like this is magic, or this is just like this makes sense?
Yeah.
Right? And it's not even really math rules. It's math logic, really, and it's math rules that we made up.
Yeah.
It's not rules that I'm telling you need to do this. This is rules we're kind of just discovering. Does that make sense? No. I didn't make factoring easy. I made a special type of trinomial called a perfect square trinomial easy to factor.
Can you always use the divided 2 rule for the...
Well, for this completing the square thing, we can.
Okay.
If you understand this process, then you've understood the hardest part about this completing the square thing. And a lot of students always get freaked out when they're doing this completing the square thing. But let me show you what the whole point of doing that is and why it's important. All right, let's try this one. Let's do this example. X squared minus 6x plus 8. All right. F of x equals x squared minus 6x plus 8. All right. Let me show you how to complete the square. First of all, what form is this a parabola? Yes. How can you tell? Because of the square. Anytime you have an x squared, it's a parabola. If I didn't have that x squared, that's a line. You know, that actually looks like y equals mx plus b. But now it's a parabola. Done. All right, good. What form is this parabola in? Oh, okay, Sophia's already got it. It's in standard form. It's ax squared plus bx plus c.
Mhm.
In this case, a is 1, b is -6, and c is 8. Okay, good. Well, I haven't even started completing the square yet, but, I mean, you know, we're getting there. Can we factor this? I can go an x and an x. I can have a negative and a negative. What are factors of 8? Oh, I guess we could factor this, huh? 4 and 2, yeah. Yeah, oops, 4 and 2. 4 and 2 works. So I guess this thing does work, but let me... I actually don't want to use something that can be factored. How's about this? Let's make this a little bit harder. I'm going to change this problem up a little bit. I'm going to put a 9 there. Now can we factor this? Ha-ha! Oh, wait. Yeah, you can still factor this. Never mind. That usually never happens. All right. A 10. Oops. Excuse me. Sorry. All right. A 10. Ha! A 10. You can't do it then. Suckers. All right. Yeah. A 10, well, 2 and 5 works, but you can't add and subtract 2 and 5 to get the number 6 in any way possible. Right? So, boom. Deal with that, suckers. All right, I'm sorry. I didn't mean to be like that, but I'm just saying.
Flaming you.
Yeah. All right. So, check this out. Here's how we complete the square. This isn't a perfect square, and we're upset about that. We're like, man, that sucks. If it were a perfect square, it'd be easy to factor. So here's what I'm going to do. I'm going to rewrite the equation, but I'm going to put a big space in between, and you'll see why I put this big space. If there were another number, not 10, but a different number there, then I could factor it, and I'd be happy. What number would that be, by the way? Refer back to our old rules. It would be 9. Okay. 9. Ha! If there were a 9 there, I would be stoked.
Yeah.
But there's not a 9 there. And I can't just go around adding 9 to that.
Mm-hmm.
That's not fair. So Sophia's saying, well, what if we add 9 and subtract 9 at the same time? Then what did we do to the equation? What is 9 minus 9?
What?
What's 9 minus 9?
0?
It's 0. When I add 0 to the side of the equation, did I really change anything? No.
No.
So am I allowed to add 9 and subtract 9 at the same time?
I don't do anything.
Yeah.
Yeah,
maybe
I
no
can.
way.
Exactly.
Yeah.
What Sky is saying is, yeah, you can, but it won't do anything. Yeah, yes, you're right. You're absolutely right, and that's the point. Is I'm not trying to change the equation. I'm just trying to make it look different.
Mhm.
So, like tomorrow, if you come back, you're going to be the same person. You're just going to be wearing different clothes.
Yeah.
Well, hopefully, after you showered. Hopefully.
Hopefully.
All right. So what I'm saying
Oh.
here is we need to. We're just changing up how this thing looks, but we're not changing the equation because that's not allowed. We can't just add 9 willy-nilly to one side of an equation. That's not fair. But we can add 9 and subtract 9 all day,
Mhm.
and it won't change anything. All right, but check this out. See the part that I underlined? We're happy about that because we can factor that. Let's factor that. What is that? X minus 3 squared. Alana, I totally agree with you. It's 3 and 3. It's x minus 3 and x minus 3, but then I combine that to be x minus 3 squared. We still have the negative 9, and we still got the plus 1, or 10. Got it? Now, we can combine these part-like terms over here. X minus 3 squared plus 1. Because negative 9 plus 10 is positive 1.
Yeah.
Look, we have taken this same f of x and turned it into vertex form. We didn't change the equation. We just added 0. And that didn't change anything. It just didn't change how it looked. If you don't believe me, and I encourage you not to believe me. If you don't believe me, let me FOIL this out for you. I'm going to do it on the side. X squared minus 6x plus 9. You guys know how to FOIL that really quickly? All right, fine. I'll do it slow. That's fine. X minus 3 times x minus 3 is equal to first, outer, inner, last. X squared minus 3x minus 3x plus 9. We cool? And then x squared minus 6x plus 9. I still have that plus 1 on the outside that I have to deal with. So really I have x squared minus 6x plus 10. And now do you believe me that they're the same thing? This was just more of a check on the side.
Yeah.
Okay. So really, this is the same equation as above, it's just a different form.
Mm-hmm.
But here's the beauty of this form right here. Let's graph that, and we can graph that so quickly. What does that 1 do? It moves it up 1 unit. You take your regular parabola and you push that sucker up 1 unit. What does that negative 3 do? Feel free to answer if you want. It moves it to the right by 3 units. We covered this in depth right before you came. It moves it to the right by 3 units. Exactly. There we go. Boom. And it is a happy phase parabola. That is not vertically shifted or vertically compressed. It's a regular happy phase parabola that is moved to the right 3 units and up 1. The vertex is at 3, comma, positive 1. Happy phase parabola. So, we want to be able to put things inside of vertex form, and to do that, we use this powerful method called completing the square, which always used to seem like magic to us, but now, after I've explained it to you, we realize, hey, wait a second. I understand where this is all coming from. I understand why we're doing this. All right, let's try this a few more times, just so we can make sure we've got it. Let's do... I'm gonna do a hard one. All right. Okay, let's do this one. X squared plus 12x minus 10. X squared plus 12x minus 10. So, and this is f of x. Got it. So, first step, what do we do? Do you guys remember?
Eggs.
Lucas saw the answer in the handout. What do you do?
Don't you do the parentheses and then x, or do you do something else?
No, you do something right before that. It's a dumb step, but it's a small step.
Something I forget.
You put a big space right here.
Yeah.
Because see this 10 right here, that's not something we want to deal with, right? Or we don't want to deal with it now. Now, darn, if there were a number here, I would be so happy. A certain number. What number is that? And Sophia's already suggested it.
36?
36. Very good. Positive 36 or negative 36?
I don't know. Negative? Positive?
I'll tell you what, it's always a positive. Sophia says positive, always positive. Sophia, why is it always a positive? That's a good question. Okay. Because when we do this thing right here, x, what should go here? Plus 6, right?
Yeah.
When we square, to get this number up here, we square this number down here, right?
Mm-hmm.
Anytime you square a number, it will always end up positive. Unless we're dealing with imaginary numbers, which we haven't even gotten to yet, so don't worry about those. But when we're talking about regular numbers, anytime we square it, even if there were a negative 6 down here, when we square it, it's going to be a positive 36.
Yeah.
So Sophia's absolutely correct. You're always positive, making it positive. But we can't just add positive to one side. Are you crazy? So you have to subtract positive, or you should subtract 36 from that as well. Does that make sense?
Yeah.
All right. So we did the stuff on the perfect square trinomial. Now we have to do the stuff that's outside of this thing, which is this stuff over here. Negative 36 minus 10 is negative 46. Bada bing, bada boom. Apparently this is a parabola that has moved down 46 units and moved to the left or right.
Right. Well, I don't know.
Take a
I
guess.
wasn't explained to this.
Well, what do you think? The plus 6 is going to do what?
Positive.
You're going to think it's, well, is it going to move to the right or the left?
I don't know.
No, I have a point as to why I'm putting you on the spot. Just take a guess. There's no wrong answer.
Okay, right. I don't know.
Actually, there is a wrong answer. That was the wrong
see?
answer.
I don't know.
But don't worry about it. You said positive because it would make sense that things that like positive 6 would move to the right 6, right?
Mhm.
But that's something we've discovered after we have been playing with these equations. Is when moving things. All right, if the thing's inside the parentheses over here, it's going to move it right and left. If it's outside the parentheses, we figured out that it's going to move it up and down.
Yeah.
And then if it's right in front of the parentheses, that's the A thing, where it gets it skinnier or fatter and that kind of stuff. And I've talked to you about gummy bears.
No.
I haven't told you gummy bear story?
No.
No, no.
Okay. Give me a second, folks. I'm going to explain to her the gummy bear story in just a second. Yeah. Sierra's like, not again. He's told this like 4 times. All right, Lucas doesn't like gummy bears. All right, fine. Fine, I'll tell you what. I'll explain to her after class then. All right. Some people are like, I love the gummy bear story. When moving things to the right and left, here's the point I wanted to try to make. You thought this was going to go to the right. It actually goes to the left.
How can you tell?
That's just kind of something that has happened.
But last time it was to the right.
What do
The
you mean?
last problem we did, it was moved to the right.
The last problem, it was moved to the right because there was a negative 3 in there.
Oh, okay, so the negative, okay. So if it's a negative, it moves to the right? And if
Yes.
it's positive, it moves to the left.
Yes.
Okay, there we go.
Which is funky.
Yeah.
And it's just kind of one of those things where my students have just kind of accepted that after a while.
Yeah.
Moving it to the right and left does opposite of what your intuition was.
Yep.
I was actually hoping you would get the answer wrong when I said, what does plus 6 do? Because I knew that was going to be your intuition.
Mhm.
It's going to move to the right.
Yeah.
And that's everyone else's intuition. That's my intuition. That's what I said when I first looked at this.
Yeah.
But it does the opposite of that. And now that I've made a big story and a big, commotion about this, you won't forget this conversation. Okay, good. All right, we're good on completing square. Actually, we've done it. We're done with completing square. Chapter 4. We're good. There is an extra complication though. Pretty much you can complete any square now at this point. Let me see if there's a harder version.
Yeah, how do you set up, or how do you figure out a problem if it's not set up that exact way?
Well, I'm going to make up a problem off the top of my head. How's about this? F of x is equal to x squared minus 5x plus 7. This one you cannot factor. I guarantee it. Because 7 is a prime number and 5 is a prime number too.
Yep.
Yeah, and 1 is a prime number. I'm dealing with a bunch of prime numbers. That's a nightmare to try to factor. All right. So, here's the extra complication though. First step, we put our big space. So I have x squared minus 5x plus 7. The big awkward space. All right. Next step. What number should go here? All right, fine. What number should go here under the triple line? Sophia's recognizing there's a problem. Sophia says positive 2.5. What about negative 2.5 or negative 5 over 2, which is also known as 2.5? Because I told you, you take that number and divide it. If it's negative 5, you divide it by 2. Okay, fine. 5 over 2. What is it? Well, it's a decimal. I don't like dealing with decimal. We'll deal with it. Okay, so it's negative 5 halves. Don't freak out. It just is. So what number should go here? All right, fine. That would be positive 25 over 4.
Okay, yeah.
right? Because if I square negative 5 halves,
Yeah.
that would be 5 squared divided by 2 squared, and so that's 25 over 4.
Yeah.
Done. I subtract 25 over 4. Okay. This thing that I have here factors out to this right here. Are we cool with that? Now I gotta find common denominators over here, and that's a pain in the butt, but okay, whatever. I'll tell you what. If you don't like dealing with fractions, then tell me the decimal answer. I'll do the you use your calculator. Tell me the decimal answer. I'll do the common denominators. Let's see. 7 times 4 is 28, right? So this is 28 over 4. So this is 28 minus 25, which is 3. So this is negative 3 or positive 3/4. Did I do that wrong? My answer that I got is x minus 5 over 2 squared plus 3/4. You guys use calculators. I use my head. I'm trusting you. Maybe I shouldn't trust you. Oh, wait, that's right. Oh, I shouldn't have trusted you. Are you kidding me? All right. Okay, all right. I'll tell you what. Let's go into Desmos, and we'll see how amazing we are. You ready? Desmos, graphing calculator. I'm going to graph the top one up here. X squared minus 5x plus 7. All right, then I'm going to zoom in right here. Now, this parabola, yes, I'm recording class. I hope I am. Oh, shoot, I forgot to record on the thing. But I'm doing the recording for the YouTube, which is the only one you guys watch anyway. Yeah, I'm doing the recording for the YouTube, so. You guys don't even watch the other ones, do you?
Oh, no, I just
The conferences? Yeah, you guys probably should watch YouTube. All right. So look at this. Check this out. You ready? Here's the parabola that this thing represents. I just graphed the top one. I didn't even graph this one down here. Would you say that this parabola, is moved to the right by 2.5? Look at where it is. Would you say that it's moved to the right 2.5 units? Well, this is 1 right here. Here's 2. So that must be 3. It's moved to the right 2.5. And then if this is 1 up here, how high would you say this thing is moved up by? If my cursor is on 1, how high is the thing? By
like
3/4,
yeah.
0.75. Yeah. Hey, look. Completing the square told us to move it to the right 2.5 units and move it up 3/4 or 0.75. We are amazing. We're able to do this without a graphing calculator. I feel like a robot genius. You know those like emotion charts? How do you feel today? I think I would feel like a robot genius. So maybe let's do one of these. Little eyes. And I'll do like little. Now I just look like a Frosty the Snowman with stuff. Maybe I'll put little antennas. I'll put crazy hair because I'm a genius. I'm a robot genius. Yeah, alright, cool. There's one extra complication that makes this stuff extra difficult, although you've realized that none of this stuff is really that bad. Well, I guess there's 2 other complications. Let me see what they do. Let's see. All right. We need to talk about, apparently in Chapter 4, and I need to finish Chapter 4 today, so I apologize if you folks, your brains are exhausted, and I know that class usually finishes after an hour, and I do have, an hour and a half of time allotted to me, so you know what, I'm going to take it, because I get to, because I'm allowed, because, math classes, well, we can't slow down, we have to finish this stuff up. So I apologize if your brains are broken or whatever. I'll give you a break before chemistry. How's that? When this class is finished, we'll take like a 10-minute break or 15-minute break or whatever. All right. Okay, let's see. Let's go to File, New. Don't save this. All right. So, here's another thing that I need to talk about with you is the square root of negative 81. What is the square root? I need that break. I need a lot of help for Cam. Okay. All right, yeah. What is the square root of negative 81? Here's the problem. There is no square root of negative 81. There is no number that causes, when you multiply it by itself, will give you negative 81. I mean, you could think of negative 9 as being a possible candidate, but even that doesn't work because negative 9 times negative 9 is positive 81. So we came up with this idea called an imaginary number. It's a horrible name. Also, the word complex numbers, it's a horrible name because it freaks students out. It makes people think, oh, it's imaginary. I don't even need to worry about it. Or, oh, it's complex.
It must be hard.
It must be way too hard for me to think about. All right, here's what it is. We introduced this value called I, which stands for the imaginary number, which is equal to the square root of negative 1. Okay? Now, the square root of negative 1 is equal to I. What is I squared? That would be the square root of negative 1 times the square root of negative 1, right?
Yeah.
What is the square root of negative 1 times itself? That's just negative 1. If you have the square root of anything, k, times the square root of k, it's equal to whatever's inside that square root. So, the square root of negative 1 squared is negative 1 itself. Does that make sense?
Yes.
Okay. Yeah, let's continue this game. What about I cubed? What is I cubed? Well, that's equal to I squared times I. You guys see what I'm saying? What is I squared? What is I squared?
I cubed?
No. Negative 1. So this is negative I. I cubed is negative I. Got it?
Yeah.
I know, it's weird. There's one more. Or there's a bunch more, but I to the fourth power. What is I to the fourth power? I to the fourth power is I squared times I squared. Agreed?
Mm-hmm.
I squared is negative 1.
Yeah.
So really I'm dealing with negative 1 times negative 1, which is also known as positive 1.
Mm-hmm.
Very good.
Okay.
All right. What's I to the fifth power? Well, that's I to the fourth power times I. Agreed?
Yeah.
What's I to the fourth power?
Negative 1.
1. We talked about that.
Yeah.
So it's 1 times I, or
1 times.
I. What's I to the sixth power? After a while, you guys get this game.
Yeah. Okay.
That would be I to the fourth power times I squared. We know what I to the fourth power, it's just 1. So I squared is just negative 1. Do you see a pattern here?
Yes.
What is I to the seventh power? Well, that would be negative I. What's I to the eighth power? Positive 1. What's I to the ninth power? Come on, what's the pattern here?
Just 1,
Nope, it's I.
which is 1, right?
No, it's not 1, it's I. I is not
I
the same as
equals
1.
Negative 1.
No, I
Right there.
is equal to the square root of negative 1, my friend.
Okay.
I squared is equal to negative 1.
Okay.
Okay?
Yes.
All right. We're playing this I game. And apparently we see a pattern. But anyway, that's neither here nor... Well, actually, that is relevant to our case here. But the square root of negative 81 is 9i. That's what it is. Because if I square this, 9i squared, so 9i times 9i, is equal to, what's 9 times 9?
81.
81. And what's I times I? As in I squared.
1.
No.
-1.
I squared is -1. So what's -1 times 81? -81.
Mhm.
So do you see how this thing fixes our problem about negative square roots?
Yeah.
Okay. What is the square root of -144? Okay. Square root of -144 is 12i.
You doing class today?
I am doing chemistry class in
Alright.
2:15.
Can I leave my
Yeah,
car here
sure.
to go eat?
12i. Because 12i squared is 144, -144. Because the 12 times 12 takes care of your 144 part.
Yeah.
And then the I times I takes care of that negative portion.
Yeah.
Done. We're good. All right.
My mind is blown.
Have you folks not covered? You've covered this before, right?
Yeah,
Never.
we covered it. It's just you forget about it and it fades off. You know. What I'm
You
saying?
you have never covered this.
Oh, I have,
No.
but
Oh, he has.
I haven't.
yeah, I have.
All right. All right. What about this? Let's try this one. What is this one? Looks confusing. 2 minus the square root of -9 over 3. Oh, that looks horrible. What's the square root of -9? It's not 3.
2.
It's 3i.
Oh. I always forget the I.
Okay. Now, I need to simplify this 3 divided by 3. So this is equal to 2 minus 1i, or just 2 minus i. And I can't combine these because this is a real number and a complex or imaginary number. We have our test in.
Hello.
That's great.
Let me put 'em right here.
Yeah, under the table.
Okay.
It's a box.
All right.
Tests.
A test.
Those are fecal matter tests.
No, that's the kind of box that you dump kerosene on and burn in your front yard.
That is fecal matter tests.
No,
Fecal
I
matter
would literally
tests.
burn that and like I'd be bouncing around it like some native Indian person because I mean burning tests is kind of my thing, dude. You know, who wants to take a test?
You're stirring.
I don't.
Honestly, who wants to take a test?
I don't understand anything he just said.
Secretly, he's
understand
a
it's simple.
psychopath.
All right. Anyway, we've got our real part and our imaginary part. There we go. And we can't combine them. We got to keep them separate. They're like not like terms. How's that? They're not like terms.
They're like,
They're like not like terms.
So like,
Yeah. No, we have our test kits in, and our test kits are for our 7th graders. But I've been waiting like 2 months for them.
so if they get those,
So-
what do we get?
But how did I get 9i times 9i equals -81? That's what Sophia's saying. Well, let's go over that again. I'll do something else. How's about like this? Yeah, fine. 9i times 9i is equal to, all right, the 9 times 9 is 81. We're not afraid of that. The I times I is what?
no way.
The I times I, that's -1, so that's the -81. There's the negative. I think what you're confusing this with is you're saying I can't combine these, but remember I'm multiplying these right here. Whereas over here I'm adding and subtracting them, so I can't combine them. Does that make sense? Yeah, Sophia, if this were 2 times I, then I would write that down as 2i. And I would combine them. But this is 2 minus I. That's something entirely different. Okay, why does this come into play? Where does this come from? All right, let's talk about this stuff. You know what? I hate to do this to you. I'm sorry that math is taking so long. I feel like it's a good discussion, and I feel like if I just blow through this stuff, you might be confused. So I don't want to just kind of like say, all right, screw you. I'm just going to go as fast as I can and finish this off. I want to take the time to work with you folks, but I need to get through all of this time. So it takes a long time. I apologize. All right, let's do this one. Use solving the quadratic. All right, let's try. Why did they teach us the square roots the imaginary numbers, though. All right. I'll tell you what. Here's another one where I'll make it up off the top of my head. What about this? X squared minus 2x plus 3 equals 0. Okay. Let's play that complete the square game that we've been playing. All right? We add a big space. X squared minus 2x. Big space. Then what I'm going to do is what number should I add here? One. Very good. Because the next step over here would be x minus 1.
Yeah.
So, because negative 2 divided by 2 is negative 1. Square of that is positive 1. So I have my plus 1 over here, but I have to subtract 1 at the same time.
Mm-hmm.
Then over here becomes x plus 2 equals 0. If I were to graph this, actually, let's not, if we would have to graph it if it were equal to y. Now, if I were to graph this, this would be moved up to, and how would it go right and left?
So negative is to the right.
Correct. It would go to the right 1 unit. Very good. So if I were to graph this, it would be 1, 2, and a 1 right here, and so it would kind of come down like this.
Mm-hmm.
Got it?
Yeah.
It wouldn't have that dot right there.
So is that completed then?
Yes, this has completed the square. I've completed the square on it, and I've put it in vertex form. But here's the problem that I have. If I wanted to set this equal to 0, because in the previous problems, I gave you problems like this, and I said equals 0, and then I said solve them. That was all of homework 4.2. So let's solve this. Let's set it equal to 0 and solve it. Because when we set the y equal to 0, that's how we find the x-intercepts. Whenever we want to find the x-intercepts, we set the y equal to 0. If we want to find the y-intercept, you set the x equal to 0. Okay. So if we set this equal to 0, this becomes x minus 1 squared equals negative 2. I took the 2 over to the other side, if that's all right with you. I'm going to take the square root of both sides. X minus 1 is equal to plus or minus the square root of negative 2. Therein lies a problem. We've got an imaginary number. I can take this 1 over to the other side. It would be x equals 1 plus or minus, well, I guess you can say the square root of 2 times I. Because this I takes care of that negative part in the square root. Yeah.
Yeah.
So maybe if I were to use numbers, it would be 1 plus or minus 1.44 times I. Because the square root of 2 is 1.44.
Yeah.
Don't ask me how I know that.
It's just, yeah.
I'm just that smart. I don't know. I just memorized it after a while. Why is this imaginary? Well, Sophia kind of hit it on the head. When does the y value of this parabola equal 0?
Y equals 0.
When does this parabola cross? Oh, you're right. Absolutely. I'm sorry, Lucas. It is 1.41. I shouldn't have messed that up. I'm glad you remembered. Sophia's saying it never crosses. It never crosses the x-axis.
Mm-hmm.
It comes down and is like, psych, and then just bounces back up, and it will never get there. Which is why we have an imaginary number. Does that make sense to you?
Mm-hmm.
Does this make sense as to what's going on here? So when I have an imaginary number, if I ask you, well, when does this thing cross? Then you say it never does. Yeah, exactly. Sophia's saying, hey, the vertex, you're pushing the vertex up, and it's a happy parabola. If it were a sad parabola, that's a different story. Then when does the thing cross the x-axis? Right here and right here. You know, we understand that. But the thing is, when does it cross the x-axis now? It never does. Okay. Okay. There is one last complication to this stuff, and it makes it really hard and really funky. Um, there we go. This is the one. Okay. Negative. All right, let's do this one right here. Let's do this one. 2x squared minus 16x plus 19. 2x squared minus 16x plus 19 f of x. This is a complete the square problem, but it is actually a lot tougher. And it doesn't look that much tougher than all of the other ones we've done, but there's a small deceptive thing that makes it tougher. And you kind of, I mean, this isn't something I'm messing with you about, because like, that when I factor this, anytime there's a number in front of the x squared term and it's not a 1, it makes this thing really tough to factor. So completing the square, there's an extra complication. I'll tell you what you do is, there are no extra rules that you would have to do, really, to do it. You just need to be careful about things, and let me show you what to do with it, all right? I think the best way to teach this to you is this. Step 1, I'm going to put a big space over here, okay? Now I can't use that perfect square trick until I can't use my perfect square trick until I have a number 1 in front of there. You guys get it? So I'm going to take Sophia's suggestion. I'm going to factor out a 2. I'm going to divide this by 2 and divide this by 2. So I have 2 times x squared minus 8x plus 19. Does anyone have any problems with that? Okay, I like Sophia's suggestion. Sophia's saying, wait a second, don't you divide the 19 by 2 as well? And the answer is, well, that's what they did. It's not what I'm going to do. I'm doing something a little different. I'm doing the same thing. I'm just kind of being very... you'll see what's going on. My answer to that is no, because I closed the parentheses off here. If I were to have the parentheses over here, I would have had to divide the 19 by 2 as well. You're right. But since I closed the parentheses off earlier, this 2 distributes into here and here, but it doesn't go to the 19. And I still have the same thing above. Are we cool with that?
Yes.
So I didn't do anything freaky to you. All right, good. Now I can do my regular complete the square that I know and love to do. Darn, if there were a number here, I'd be so happy. What number should that be? $16, very good. And you subtract 16. Got it?
Mm-hmm.
This thing right here becomes a perfect square trinomial. So this becomes x minus what? Squared.
4.
Perfect. X minus 4 squared.
Mm-hmm.
Minus 16. And what I'm going to do is I'm going to change this parentheses. I'm going to change them into brackets. It doesn't mean anything different. I'm just, I don't want to get my parentheses and my brackets confused. Bracket 2 plus 19. You got it? So this becomes 2x minus 4 squared minus 32 plus 19. I literally did a step in my head without explaining it, because I'm waiting for someone to say, wait a second, where did you get that?
Yeah, I was thinking that in my head.
Well, then say it.
Did you get the 32 from the 16 and 19?
No, I didn't get the 32 from the 16 and 19. I wanted to get rid of this bracket right here. So I need to distribute this 2 into everything inside of that bracket. This is one of the things inside the bracket. This is another thing in the bracket. So I multiplied this by 2 right there. Then I multiplied the 16 by 2 to get the negative 32. That got rid of my bracket.
Okay.
You understand?
Mhm.
Does everyone online understand? Or why did you... Wait. Sophia, did I answer your question? I don't understand I don't understand your question. But did I answer it? This 16 is inside the bracket. So the 2 needs to distribute to both the things inside of the brackets. Oh, why did I put the 16 inside the bracket instead of outside the bracket? Well, it's because I'm doing my complete the square bit all within this bracket. I'm saying I don't like dealing with a number in front of my x squared term, so I'm factoring it out, and we're good with that. And then I'm going to say, in this small little world that I have inside this bracket, hey, there's no number in front of that x squared term. I'm going to do all of my complete the square stuff here within this contained bracket or whatever. Does that make sense? And then what I have to do is to get rid of the bracket, I need to distribute that 2 into everything inside there. Not everything inside there, not inside that parentheses, but to the 2 things that are inside there. And there's 2 things inside that bracket. There's this thing and that thing. Bradley, I apologize if this feels like the longest class in history. Technically, I'm allowed to do this because I have class scheduled till 2:10. All right. And I don't feel like I'm like boring the heck out of you, I hope. All right, anyway, let's go. 2 times x minus 4 squared. What's negative 32 plus 19? I'm not very good at calculating numbers, I'm sorry.
Negative 13.
Negative 13. All right, awesome. That, my friends, was the added complication of apparently Sophia doesn't like the gummy bear lesson. I'll explain it to you after we're done.
I'm good.
All right. This, my friend, is how to do completing the square if there's a number in front of the x squared term. And it's a little bit difficult. Actually, it's not really that difficult. I don't think it's that difficult.
It's just extra steps.
It takes practice.
Yeah.
All right? And this problem is amazing because what you can do is now you can graph this, and it's pretty easy. You move it down 13 units, you move it to the right 4 units, and you vertically stretch this thing, making the parabola skinnier.
Yeah.
There we go. All right. I'm going to do one more, and I'll tell you what. I'm going to do one more, and I'll do it quick. Actually, look. We got the same exact answer as them. We're good.
So we get it right.
So we got it right. We did ours a little bit differently. They included the 19 inside of the parentheses. And notice how when they included the 19 inside the parentheses, Sophia, you were saying they need to divide the 19 by 2. They did that. And then they distribute this 2 into everything over here, and that became 13 over 2 times 2 is just regular 13.
Do we get one of these too?
Huh?
Do we get one of these too?
This thing right here?
Yeah.
This is your workbook. These are the handouts in all of your...
But it has the answers on it.
No, I'm doing the examples.
Oh, okay.
I'm not doing your homework for you. I'm doing the examples.
Oh.
I'm just working my way through the homework or whatever. All right. I'll tell you what. Let me do one more for you. I'll do it quick because I know that you folks are like your brains are fried. And then and I won't ask you every single step. I'll just do the whole thing for you. Sound good? All right. Let's take their example. Let's see. Negative 3x squared minus 12x minus 8. I wonder if I even gave you homework on this. I wonder if this is the part I'm doing your homework for you. All right, whatever. Negative 3x squared minus 12x minus 8. All right. F of x equals negative 3x squared minus 12x minus 8. Well, I will give you homework on this because this is important stuff. All right, let's do this. I'm going to put a big space. Negative 3x squared minus 12x minus 8 is way over here. Got it? I'm going to factor out that 3x, but I'm only going to do it to these ones right here. So I'm going to close off that parentheses before the minus 8. I'm going to factor out a negative 3. Let me hold that for a second. I've got an x squared.
No.
Okay. I've got an x squared. Over here, I'm going to have a plus 4x. Now, I know I told you I wouldn't ask you questions, but do you understand where I got the plus 4x?
Yeah.
All right, good. Within my microcosm of niceness where the x squared term has a 1 in front of it, I'm going to deal with that. I'm going to do the complete the square dance. Plus 2 minus 2. No, plus 4 minus 4. Sorry. I was thinking about this step right here. This is x plus 2 squared. But to do that, I would have to do the plus 4 and the minus 4. You guys understand what I... All right, good. Still got my minus 4 out there. And that's inside of a bracket that has a negative 3 in front of it. Cool? Stop me if I'm going too quickly. I'm not asking questions. I'm not stopping or even asking you how to do all of these things. Negative 3 times x plus 2 squared plus 12 minus 8. So this is negative 3x plus 2 squared plus 4. That's it. This parabola is moved up 4. It's moved to the left 2 units. It is a sad face parabola that is vertically stretched.
Yeah.
That's it. All right. Class is dismissed. You guys can get out of here. And I'll tell you what, I will assign homework. I'm going to assign these 3 problems for homework on chapter 4.10. And guess what? I did one of those problems for you right now. So now you guys can't. Oh, yeah, it is only 3 problems. So now you guys can't complain. It's like, oh, Mr. Dodger, send us some more homework. Actually, I'll tell you what. I'll think about adding homework, or maybe I might make those a part of the test. So make sure you do this. Got it? When does chem start? Chem starts in 15 minutes. But I'm done. I've talked my way into oblivion. There's only one more thing that I want to cover with Sky. And it's the gummy bear thing. And all of you folks here come normally, so you guys... All right. Can I cover the gummy bears with Sky? Because I feel like her brain is going to explode.
Will it?
I don't know.
Can you handle this?
She's got that look on her face, the crazy look. And then I'll go over question 4.9, and then we'll start covering chemistry. Whew! And don't worry, for those of you in chemistry, I'm going to give you folks like a 10-minute break or a 15-minute break or something like that. Because my voice hurts. All right, gummy bear. There's when in our equations, the ones that we covered today, like for example, a times x plus h squared plus k. I'm going to make a little slider bar for these, and this is actually pretty cool. Let's see. I'm going to make this 0. I'm going to make this 0. I'll make this bigger. All right. Now, you know this thing. If k is bigger, it pulls that parabola where? As k gets bigger, it goes up. We cool?
Mm-hmm.
And as k gets smaller,
Back down.
it goes down. All right. Sophia, I'm going to answer your questions, I promise you. I promise you. Oh, okay. Bradley, I'll answer your question. Hold on. Let me just go over the gummy bear thing with Sky. So we're good with that.
Mm-hmm.
All right. Now, the thing inside the parabola, if this thing becomes bigger, it goes where?
To the left.
Yeah, and that's a little funky.
That's the
And
negative.
this thing becomes smaller. This goes to the right.
Mhm.
Now, we actually don't. Us mathematicians, we don't like that either. So
Just
to
the way it
account
is.
for that, in the actual original equation, we put a negative in front of there. Now what that does is when this gets bigger, it goes to the right. But it's because it's getting a 5.2, but it's x minus 5.2.
Yeah.
So we accounted for that weirdness.
Yeah.
And that's the actual form of the equation.
Mhm.
All right. Now what does this a do? That's the question that we wanted to ask. So I'm gonna. All right. Well, there's my problem. Do you eat gummy bears?
I have before.
You have
Yeah.
when you were a kid. Yeah, right. And there's a right way to eat gummy bears, right? Pass me that army man right there.
Does it matter who?
The right way to eat gummy bear is you grab the gummy bear by the head, you grab the gummy bear by the feet, and you slowly pull. And you look at the gummy bear and you say, "Please no!" Ah! And preferably you grab them on the side so that you can see the face, and you be like, "No!" Ah! And then you stretch it out as far as you can, and then it pops, and then you eat the head, and you eat the feet, and then you're good, right?
Uh-huh.
That is the right way to eat gummy bears.
This is why you're vegan.
You are taking you never in your head, or you never had a childhood where you never eat gummy bears like this. Oh, yeah. I told that everyone has. I know you've done it.
I'm sure, yeah.
Yes, when you eat gummy bears,
Mm-hmm.
right? So what this does is, and what happens to that gummy bear when you vertically pull it apart?
It just stretches. It gets bigger and bigger.
It gets bigger and bigger, but what happens to its fatness?
Oh, it declines. It like shrinks.
It shrinks it.
Yeah.
It gets skinnier.
Mhm.
So what I'm saying here is, see this A?
Mhm.
If the A is a positive number and it gets bigger, think of this as I'm stretching this parabola,
To make
like
it
a gummy
skinnier.
bear.
Okay.
but what it's doing, and I think of it as stretching it vertically, but really what it's also doing, what you see it doing is it's getting skinnier.
Mhm.
But I want you to think of it as a gummy bear being vertically stretched.
Yeah.
Got it?
Yep.
And there's a reason for that, and I won't explain that reason for another couple of months.
Okay.
But it's a fun lesson. All right. So what if A were a fraction, like 1.5 or 0.5? Well, that's the other way to eat a gummy bear. You take it and put it between your index finger and your thumb, and you squish it,
Mm-hmm.
and then it becomes short and fat.
Yeah.
And look what happened to our parabola.
Yeah.
It became fatter.
Yeah.
So that's what the A does.
Okay.
The A vertically, if it's a big number, it vertically stretches it. If it's a fraction, it vertically compresses it. And if it's a negative number, it flips it upside down. And it follows all the same rules. Like, for example, this is a fatter parabola because this is a number smaller than 1.
Yeah.
This is a fat parabola. It's a number smaller than 1. Then when I get to 1, it becomes the regular parabola. And then as I go up, it,
Mm-hmm.
So these are all fractions over here. And they got fatter. You're getting a fatter and fatter parabola.
Yeah.
Eventually, if you get to 0, then you just have a horizontal line. It's so fat as a horizontal line. Does that make sense?
Yeah.
All right. That's my gummy bear lesson. Now, Bradley, where did the 12 come from? Is that what you're asking?
Do you want a piece of gum?
Sure. You're talking about this 12? It came from the -3 times -4, which is positive 12. Did that answer your question? Because I got rid of the bracket, so I distributed the 3 to both things. Why didn't the -3 go away? What? No, it's there. It's -3 times -4, which is positive 12. You still want it to look like it's in vertex form. Yeah. This is in vertex form. And it goes to both things inside the brackets. All right. Sophia, I've got 5 minutes. What is it? Oh, you can't see the screen. Oh, that was a jerk move. I'm sorry. Huh.
Did you see how low grade the tsunami was? It was literally like not even at the lowest grade.
It's a 8.3 magnitude.
All right.
Let me see.
It's one step above under one. It's the second highest.
No, you're talking about the earthquake, or you're talking
No,
about
the tsunami. It's one under a warning right now. They're upgrading it.
Did you just get it?
Yeah.
All right.
And
Here's my screen, Bradley. Sorry about that. The 12 came from the -3 times -4. I distributed the -3 to both of the things inside of that bracket. Sophia, I'm going to take a look at that, and it's probably because I got the quiz wrong. I mean, that's really what it is. Actually, I'll tell you what. I'll take a look at that right now.
I'm not gonna die.
I'm going to tell you right now that it's probably because I put the answer wrong. Let's figure it out. And if you want, I'm going to solve out 4.9 and show the people the answers, so you might want to just watch this real quick. I know you have to go. I apologize.
Oh no, no worries.
I would really like for you guys to stay for chemistry.
I need to evacuate my dog out of the flood zone.
Oh my god, you got hypochondria now.
Hey, I had tsunamis in Washington State, and they wouldn't joke around.
I just feel like, no, tsunami's not a joke. But
I mean, I've been through an actual one before, like in Washington State when we had the one here. Yeah, it hit there too, and it was actually really scary.
But think of how many like hurricane warnings we've had in
No, but
No,
those,
that's
those
the
are-
wrong
those
way to
aren't
think about it,
warnings,
though.
No, because you can, you know.
Oh yeah, for sure, but I'm not gonna freak out about it right now.
oh, okay. Sophia, are you talking about this one? What is the y-intercept? What did you get?
Coconut.
1 and 9. All right, I'll tell you what. I'll need to. All right, let's do this. Let's factor that. X squared. What was it? X squared plus 6x plus 8. Okay. X squared plus 6x plus 8. Factoring. X, 8, and not 8, 2 and 4. Right, I was going to say it can't be 2. Yeah, you're right. It's 2 and 4. So your intercept is -2 and -4. Whereas I put, oh, I see. Usually what I do is I tell the computer, you can either give them a correct point if they put in -2 or -4, and I do that twice. This time I accidentally only put -4 up here and -2 down here. So it was technically the right answer. You probably just put -4 or -2 up here and -4 down here, and it graded it wrong. If you were to switch those things, like you put a -4 over here and a -2 down here, then it would have graded you correct. But that's my bad. All right, that's not a drastic mistake. I just fixed it. Done. All right. I got to end class so I can start up the chemistry class and tell them to take a break. Okay. Bye.
This chair outside.
Was that?
Put this chair back outside.
Yeah, you leaving now?